Welcome everyone to another Linux live stream here. In the news is of course Linux 5.17 and as per usual it's the latest and greatest stuff and best invention since sliced bread. And I actually wanted to come here and talk positively about AMD's pstate driver, new pstate driver for modern Ryzen Zen 2 and 3 CPUs. And so what is it's in the news of the latest and greatest. And initially, after it didn't work and I got it to work, initially I was for a moment hyped, like, hey, amazing stuff. So what is that? This is, unfortunately in the x86 world, everything is so complex. We have multiple things, multiple drivers, multiple implementations, since ACPI and AMD Power Now drivers and stuff. And initially it was like dedicated drivers are better, like AMD K8 or whatever, Power Now. And then eventually it was like, nah, this stuff is not good and maintainable and complex and stuff. Then use some ACPI stuff like ACPI driver generic. And now it's somehow, that still works, needs custom implementation and stuff, but still works. This driver is an AMD specific pstate driver, similar to Intel also has now their, after I think probably they initially also in the middle of this used the generic CPI, CPU frequency driver. But now Intel also has an Intel more optimized pstate driver. I somewhat despise that here. A recurring theme, complexity and minimalism. This is really crazy that each CPU needs its own dedicated CPU frequency driver stuff. Yes, stuff is complex and difficult and performance and stuff, but somehow it is crazy that for years we don't have the most optimal drivers and then we have drivers. Anyway, so this is a driver, as I outlined, that controls the CPU frequencies. And in a previous video, I already patched the Linux kernel because for me, on any of my AMD Zen 2 and 3 boards and CPUs, the Linux APIC X2 driver didn't work for ACPI limitations, previous video, and viewer confirmed for their Gigabyte, I think, board also not. So the CPU frequency driver already didn't work for me, right? I had to patch it some months ago, 6 months ago or so. So this driver is also crazy. So it also didn't just work. And this is actually by design. Turns out, and this is also why I kind of lose my mind here. Turns out, yeah, this driver doesn't like just work. I mean, I saw this message, this processor supports shared memory solution. Also the wording, right? Nowadays, the companies they pay developers somewhere in cheap labor countries, and then you get driver and documentation with, it's like, sure, it's readable English, but it's not perfect, right? For me, this message didn't trigger that this means it's not being used. I thought, hey, it supports a more optimized shared memory. I mean, also solution, right? Calling shared memory, I mean, you would call this excess or something. I mean, solution, seriously, this wording, yeah. In my opinion, this should be also returned. I mean, now I read the source, right? You could always read the source, like, hey, I constantly read the freaking source because constantly this stuff doesn't work, right? So it turns out you need to mod probe this or boot with AMD_pstate shared memory because it's not optional. It's not a more optimized solution. It is probably the only solution for this AMD 5950X. It's like, yeah. So I wasted already 30 freaking minutes to get this shit to work. Also, in my opinion, when AMD is late with something, like probably a year or two late with this driver and stuff, and then it doesn't even freaking work out of the box, right? And then you wonder, like, why am I the guy getting older yelling at companies when, like, constantly the stuff is imperfect, right? Okay, fine. After wasting 30 minutes of my life, again, booting with this, so the message, so the message is you can enable it with AMD pstate. So I thought enable the shared memory solution, not enable the whole freaking effing driver, right? It's wording, right? And review, right? Probably reviewed 4 times on the Linux kernel mailing list, and the documentation is similar, imperfect English, but anyway. Initially I thought, hey, wow, amazing stuff. So what this does is it again changes the behavior of the CPU frequencies, of course. But initially I thought, hey, wow, amazing stuff. Finally, we're getting there because the base frequency is way lower with that. Let me check. This was AMD pstate CPU frequency. So initially, before I hacked the X2 APIC, I think, driver, so usually the base clock is like, I think, 3200 or something. Only with my modified, probably for most people on Linux, that doesn't work unless they use my Linux, T2 Linux, or my patch here from this channel. Then with my modified driver for ACPI CPU frequency to work, the base clock becomes 2200, I think. And actually we can verify that. ACPI, CPU info. Yeah, 2200. So that is down from 3000, I think 3200 or so, or 3400 to 2200. And with the AMD pstate driver, the base clock is down to just 550 megahertz. That, of course, is amazing. So I thought, wow, amazing, more energy efficiency, right? Exactly what we need in these days. Less oil and gas and coal with this war times and funding Russians war on Ukraine. All energy efficiencies are amazing, especially if you run on solar power and wind power and stuff, or are off grid. But this does not really translate to better efficiency. So I couldn't measure any improved power usage, with my previous X2 APIC patch. The CPU, when idle, is already around 0 amps. Is of course, like at times it's like below 1 amp usually. So it was that before, even with the base clock of 2200. So similar to other articles, it looks good on paper. It does not translate to real improvements, unfortunately. And that is and this is also benchmarking stuff, right? I'm benchmarked already, and also share, like, and subscribe, and Patreon and good stuff. I wish I would have time to make nice graphs here. So the more you share, like, and subscribe and stuff, you sooner or later, when we hit 10,000 subscribers on the main channel there, then I probably start with fancy graphics. But right now I can't afford it. I built the Linux kernel a couple of times, and so I can't, this was the last build. So this is my reference time building the all modular Linux kernel in T2 on an AMD 5950X with 96 gigs of memory, as highly optimized as T2 is. That is 5 megabytes. That includes some surrounding administrative stuff and checksumming and stuff. But that is the same for all those builds. So this was building that with the old CPU frequency driver. 5 minutes 24, and so all the other stuff only becomes slower at times, significantly slower. So the variations here are with SCED-util and on-demand governor. The differences are, one is a driver and the other is an algorithm that decides in the Linux kernel based on CPU utilization and so on. Either good old-fashioned on-demand or new SCED-util stuff. And I also have to say, so the SCED-util for me, this here is SCED-util. Again, share, like, and subscribe for better bar graphs and stuff. Right now you need to trust me. For me, the SCED-util, because also the latest and greatest SCED-util, the new scheduler-based utility framework stuff in the Linux kernel to determine scheduling and CPU frequency stuff. For me, a regression here, 11 seconds regression. Oh, wait a second, which one was it? 516, here. 524, oh no, it's a little more, 16 seconds regression on this embarrassingly parallel workload. And that is also the thing between looking initially, hey, CPU info or some sysfs files print out some lower numbers, being thrilled, amazing stuff, and actually benchmarking this stuff, and real world is like, yeah, wow. And even, so that is, most of them is with SCED-util. Although this is relatively close here, but yeah, you see. Yeah. And even, so the last one I changed back to on-demand. So this here is SCED-util. So the difference between SCED-util governor and on-demand governor, 10 freaking seconds. So much to that. Always, on big news sites, the next big thing, better efficiency, energy efficiency, this, and this, and then you take a closer look, it's like, not really. And also, I mean, maybe eventually it will be amazing. I think Scheduler is also being worked on for probably 2 years. There's 2 years of this stuff. And even that is still, it's still 6 seconds slower than what I had previously as a baseline. And this is actually, now that I read the sources here, right? Mind you, the sources I've already only opened after this. And here you see also to do, and this is the crazy stuff, right? You give the companies your money, 300 euro for the ASUS workstation board, 1,000 euro for this CPU. Actually, in total, I gave AMD 2,000 euro because I have a 3950X and a 5950X because company and YouTube and Linux distribution. So I gave AMD over 2,000, well, minus profit margins and stuff, but you get the idea. Plus, I brought CPUs for 20 years already from AMD, right? You give them all, bottom line is you give them all your money, and all you get is drivers 2 years late. And then to do, we need more time to fine-tune processors with shared memory solution. So solution, oh my God, with community together. It's like, yeah, seriously, freak, are you kidding me, right? I mean, you had one. You also wonder how these companies develop their processors, right? Sure, the stuff is epic thread-ripping fast, but when you look at Apple, their stuff is not yet as fast, but epic thread-ripping and power efficient. And AMD is like, yeah, YOLO, whatever to do. We need more time to find. Also, 2 years late, they need more time fine-tune processor with shared memory solution. You also, so the other is MSR, model specific register, as far as I've seen here. So that means the crazy stuff is shared memory solution sounds more efficient, right? And at the end of the day, yeah, to do not enabled by default because there are some performance drops on the, also the English is like, yeah, also selecting color. On the CPU, I would, CPU benchmarks which reports from SUSE, which it's like, did nobody review this English? I always get a little bit, I'm not even native English speaker, right? But we are co-working with them to fine-tune the shared memory solution. I mean, I would call this access, right? Shared memory access or implementation. Solution really sounds strange to me. So we disable it by default. So this is also my initially like wasting 30 minutes to enable this stuff. Like, yeah, it's at least for my processors disabled by default to go, I would call it to use, right? This processor is not freaking walking to another solution. To go CPU frequency is like to fall back to freaking, do I even need to proofread the English in the Linux kernel? Go to fall back to the CPU frequency driver on those processors and module parameter to enable it in a manual for debugging. So yeah, that is really disappointing. For me, I slightly wonder if I actually so we deleted that. We also see in the benchmarking numbers again. So see that here. And again, I have only raw text because I have no time and money for bar graphs. You go share, like, and subscribe. So this is just OpenSSL speed to have another indicator. And here you see, so this is CPU frequency versus AMD pstate's scheduler. And it's slower, right? I was hoping at least maybe it's turbo boosting better because, so the crazy thing is the raw numbers are misleading. The raw numbers tell me it is idling at a lower frequency of just 550 megahertz on this epic thread-ripping workstation processor. And I see higher boost. The boost is at times indicating to me over 5 gigahertz boost now, but it doesn't translate to real-world performance gains here. The old stuff here, for example, yes, it's old algorithms and stuff, but doesn't matter. We compare here just the raw CPU speed. So 904,000 MD2s, doesn't matter, old-fashioned shit. Versus, so this is AMD, this is the newer stuff, right? Slower. We can also try and compare other stuff, potentially where MD4 is running so much old-fashioned shit here. Anyway, all of those numbers, as you see here, lower. If we compare this to the new stuff, is that, so that is AMD pstate schedule versus on demand, and you see it is immediately higher, right? So using the latest, greatest stuff, recurring theme here, regression. Really, really disappointing that I even spent my precious time on this stuff. 453,000 to 458,000. And yeah, should it be even in the Linux kernel? I mean, maybe. I mean, what is it even worse to have it in the Linux kernel? Maybe documenting, because probably not sure if there's public-facing documentation for this proprietary AMD stuff. I mean, maybe the point is at least the shared memory access solution is documented for others to work on, because as it stands right now, it's a waste of time and money. We can actually, let's ACPI, I can show you, so the ACPI CPU info. So previously I think I didn't really, so you see base frequency 2.2 gigahertz, that is old stuff. And so usually single core boosting with my water cooled, performance boost optimized and stuff, and their power offsets played all the previous good videos. I did on Linux usually not see boosting to 5 gigahertz. And I don't know if I can trust those numbers. The CPU frequency. So I have no idea if you can trust this, because the crazy thing is it doesn't translate to real world performance, right? So it looks like boosting to 5.1 gigahertz, but can you trust this? We had this previously some months, 6 months ago, a bug that this values were totally off. They showed like 6, 7, 8 crazy gigahertz stuff. I don't know, maybe it's true, maybe it's not true, maybe it's only boosting for fractions of a millisecond. I have no idea. We can also, so yeah, theoretically the numbers look lower, power efficiency not measurably better. AMD knows it is a to-do, shared memory solution still sucks. I wish, as usual, I had better news for you, but that is you basically don't need to waste your time and money on this. And we are an AMD fanboy here, right? It's not like we want to shame AMD here for the stuff. So paste the other. Let's compare actually CPU. Let's paste CPU. What was it? ACPI. Let's paste that OpenSSL, because I can't. Actually, I should check whether you can change this on runtime. Maybe not. I don't want to constantly reboot now, which is why I saved this obviously to text files. Paste that with OpenSSL. Did I not have a? Why did I not have a? Oh wait, this is the wrong one. AMD OpenSSL2. Let's for one last thing. I'm not sure if I compared that. Also best with less. 90,000. So yeah, even that, right? So that's actually what I remembered. Just wanted to have it on screen. That even when it looks artificially boosting higher to over 5 gigahertz, it's not faster. So I really don't understand those fake numbers there. When the old stuff, as you see here, 900, I mean, it's not by much, but a little bit. And I slightly wonder what I should do now. If I should go back to, I mean, maybe the most logical would be to go back to ACPI CPU frequency, because it's fractions of a percent faster. Unless I run this AMD CPU frequency stuff for testing and hoping that although this sensor, I could plug out the power, the volt power, and put a voltmeter in there and measure the power consumption, and would be interesting to know whether this 550 or so megahertz translates to wall power, like not sensor measurable, because precision and stuff, and like 0 amps, like thank you very much. I could, so theoretically I could transfer, compare the idle temperature, but the chipset actually, probably the active chipset fan probably didn't kick in yet, or actually also it says chipset fan 1. Anyway, I could run this new driver for not only testing, but like at the back of the mind, maybe it saves some microwatts, although in the grand scheme of things here, if you can't measure it, it probably doesn't make sense. And then maybe I waste more energy from stuff running longer, like a percent, so much to the perception of energy efficiency when idle with real world performance. If real world performance is a percent lower, then of course you waste some waste more power having this stuff run longer. I'm not the only one finding this, right? If you go back here to this for running stuff September last year, so apparently nothing really changed from 22nd of September. Basically, they found here the same stuff, geometric means of all tests, ACPI CPU frequency here, means, what is it, AMD pstate, yeah. So as you see here, more is better. It's like, yeah, I'm not the only one finding this. So this is on demand, so performance. So basically what they find is, also I keep performance, yeah, so I'm usually not running performance. I think is performance not running this always with the highest performance state. Anyway, their finding is overall, usually pstate stuff is a little bit slower and also didn't lead to any measurable improvements in power efficiency on this ASUS notebook even, and seen similar results on Zen 3 systems. Yes, a little bit sad, to be honest, that I thought it's in there and it must be more amazing. I also, last but not least, wonder, but not only this stuff is like 2 years late, if you think from Zen 2 to now, but you also have to wonder what these big companies are doing, right? What they are thinking, that not only is the stuff late, but then it doesn't even work particularly well, right? You wonder what they are being paid for. Usually you would, I mean, my company would already be bankrupt if I constantly don't provide working slow and regressing solutions. But at big companies, whether it is IBM, now Red Hat, through the AMD, Intel, certainly NVIDIA and stuff, it's like, yeah, people are, or Apple, people get 6-digit salaries for, at the end of the day, their shiny new CPU frequency driver stuff. It's like, yeah, to do, doesn't really work. Although maybe for CPUs that are using MSRs, module specific registers, I don't know which these are. My 5950X uses this shared memory solution. Maybe there are some CPUs where it is enabled by default. I have none of those. Where it is beneficial, maybe it isn't. But last but not least, I come back to my recurring point here. Stuff needs to be more simple. There should be a standard. Yes, I understand it is, standards also suck, and it is difficult with companies, think Intel and AMD or ARM, to agree, but there should be an like ACPI standard. And as you see, people always performance. The old-fashioned standard, although my understanding is, I think the ACPI CPU frequency driver also includes quite some vendor proprietary glue there, so it's like not a full standard. I wish there were. Also, this stuff is not that rocket science and stuff to change some CPU frequencies, in my humble opinion. I wish there were some more standard and we wouldn't have like dozens of drivers that all suck differently. And for like stuff like the Apple Silicon, we know the Asahi people of Macan and their friends, they need to reverse engineer all this stuff and write yet another ARM ACPI CPU frequency scaling driver. It is crazy, right? We have 24 freaking also solutions of different drivers. AMD Power Now, Intel whatever, even via ePower Safer whatever stuff. And hey, even old-fashioned Apple G3 or hey G5. I think even G5, although that could only toggle between 2 CPU frequency states. Long story short, we have 2 dozens of freaking drivers, all of them suck differently. And that is a problem with IT, right? We have gazillions of USB drivers. Sure, there's some stuff like human interface devices or storage devices, but even for host controllers, we have super old-fashioned stuff, UHCI, OHCI, EHCI, XHCI, sure, I understand USB 1, USB 2, USB 3, but even then we have differently proprietary USB 3 stuff, Renesas and whatnot, TI and other embedded whatever stuff. It is crazy how much non-standard stuff we have, and at the end of the day, people are only hunting and reverse engineering stuff to actually freaking work a little bit. And even if you get vendor stuff, even at embedded TI, Freescale, usually to-do doesn't really work well. To-do, we don't know what we're doing. We're happy it works at all. YOLO whatever community, good luck fine-tuning that. It is crazy. I wish I didn't touch it yesterday. I should know better, right? And that's the crazy stuff, right? You always think, you make a YouTube channel, you have only fun. For me, it's like, you make a YouTube channel, normally I would not even tested this, right? You're like, yeah, YOLO, whatever, my stuff is working. Then you're a little bit tempted of, hey, presenting this to YouTube, some more amazing stuff, and it's like, phew, how can this stuff fail so much, be so imperfect, still not work? And at the end of the day, you only spend some hour or two hair scratching of your findings, and yeah. Share, like, and subscribe. I hope eventually we see more progress in IT. And this is also a little bit why we can't have nice things, right? We had 10 years ago CPU frequency scaling in 2022. We still have stuff that's like, yeah, to do, use old stuff, not yet performant. And it's a little bit why we can't have nice things, right? Because we constantly re-implement good old-fashioned stuff, algorithms, and the new stuff, regression, right? Slower, nah. I'm not the only one, other people find it too, and yeah. Anyway, share, like, and subscribe that we can make more amazing stuff, and again, in the future I should make bar graphs, but I've already wasted too much time on that, so all Patreons and YouTube membership and super chats and stuff, welcome, and then soon with 10,000 subscribers on the Moment channel, soon we can afford bar graphs. I hope you learned something, especially not to waste your time on this stuff. Otherwise, have a good day, and otherwise happy tuning with the community and help AMD getting their pstate driver to work. See you next time.